Hello there, this is Mr. Dunaway. Welcome to Chapter 4, Section 6. As I was working on this and going through the notes, I realized a lot of these things we've actually talked about. So the expectation that you remember this vocabulary specifically is a little bit higher. As it's been repeated quite a bit, and you'll need to put these on that hard drive in your head. Okay, let's look at what those words are that I'm talking about. And first of all, I think this visual here is a really nice visual where this represents a function. And recall that in a function, we have independent and dependent variables. And what we do is we take the independent variable and we input that into an equation, like the function machine. And this could be like x plus 1 or something. So this particular blank in here, that's going to be the function rule. Okay, and that might be, like I said, x plus 1 is an example of what this would be. So we have an independent variable, which we also call domain. It goes into the function rule, and then it spits something out. So over here is a list of words. There, we just put function rule on there, and we want to place these words appropriately here. Well, what x values, I almost said the wrong thing there. X values, those are the independent variable. Those are also called the domain. Okay, so the domain are the x values, and those are also called the input. That's what goes into the function. All right, we put a value in the function, that would be x plus 1. So whatever you put in, which you control, goes in the domain. You do something to it, and then it gets an output there, which is the y value, which is also called the range. Okay, so in this chapter, we're going to start using the words range and domain a little more often, meaning independent variable or x, or range, meaning the y value or the output, or the dependent variable, as y depends on what the value of x is. Okay, so that's the review vocabulary. I'm going to be expecting you to know that, so please pause that and study it as necessary for you. The vocabulary builder section, this is kind of, we talk about this a little bit at the end. It's just talks about the words reasonable and unreasonable, and we're going to look at that as we consider what domain and range values might exist for certain situations. Okay, that'll make more sense when we get to the context of those questions. The bottom half of the first page, I'm not too worried about that. I'd rather just move on to the next page. So just cross that off and turn your page over here to number 5, as we can save a little bit of time that way. What you do need to be able to do, and this is important, is identify whether something is a function or not. And like I mentioned, we talked about this earlier, but you're going to be tested on it here in this particular section. So let's do that. Identify the domain and the range of the following relation. Well, if you look back on your first page, okay, domain is x, right? Domain is x, so all of the x values will go as the domain, and the range are the y values, okay? So 4.2 is a domain, 5 is a domain, 7 is a domain, and 4.2 is a domain again. So keep that in mind as we look at number 5. It says use the domain and range to label the mapping diagram, then draw arrows to represent the relation. Here they've listed 4.2, 5, and 7. Okay, here they've listed 0, 1.5, 2.2, and 8. So the domain, as we set up here, are those x values, which is this one. So these are the domain. And this group, the y values, those are range values. Also notice they list them least to greatest, and typically we do that. All right, and then what they want you to do is they want you to look at the original ordered pairs. When I had 4.2 input, the input was 4.2. Remember this domain, that's input. The output on the first one was 1.5. So draw an arrow from 4.2 to 1.5. That arrow symbolizes that putting that in the function machine output was 1.5. The second one, where it says 5, its output was 2.2. So draw an arrow from 5 to 2.2. The next one was 7 and 4.8. And the last one is 4.20. So you have to go back here, and from that point right there, draw another arrow from that point to 0. All right, now number 6 says, does the relation map each domain value to exactly one, there's your key word, exactly one range? And if we look right here, we see that the answer is no. Because 4.2, we put that in the machine once and it output 1.5. Then we put it in the machine again, it output 0. Therefore, this is not a function because this one domain output two different ranges. Okay, and that's what 6 is asking, and 7. If it's a function, if it were a function, you wouldn't have the domain having double arrows coming out of it there. Okay, so it says that's one way to determine if something is a function, but there's another one that I like because it's more visual called the vertical line test. Okay, and you can use a vertical line test to decide if something is a function. All right, if any vertical line passes through more than one point of the graph, then it is not a function. All right, it might sound confusing, but it's actually, I think, a lot more simple to see as we'll look at problem 2 at the bottom of the next page, this page. Here it says, okay, identify functions using the vertical line test. It says, is this relation, and they have all the points, remember the relation is just a group of points, is it a function? Use the vertical line test. Well, let's plot these points. 4, 2 would be right here. All right, I'm going to ask you to hit pause right here, map the rest of these, plot the rest of these points, and then I'll show you how to do the vertical line test. So hit pause now. Presto, there it is. Hopefully you graphed those points, and hopefully you hit pause and did that on your own. Now I'm going to show you how we can use this to determine whether or not something is a function. So remember, what we're doing here is we're asking ourselves, is this a function? That's the problem we're working toward here. Is this a function? That's what this question is asking up here. Is this relation a function? Well, notice over here I put this nice little line. Okay, and you can do this with your pencil, your finger, or you can just visualize it. It says, can you draw, looking at number 9, can you draw a vertical line that intersects more than one point? If so, draw it. In other words, I could add the words at any time. Okay, does it intersect more than one point at any time? And it's important that this line is vertical. All right, I'm going, don't intersect, boom. There, it's intersecting one point right here, but that's the only point right there, so I can continue going, boom. That's okay. Boom, okay. That's okay. That's okay. All right, let's look at the questions here and see what they're trying to tell us. Can you draw a vertical line that intersects more than one point at any time? If so, draw it. Well, this one did not intersect more than one point ever. All right, is it a function? This one is yes, okay, because I didn't intersect more than one point. So this is a function because I can move the vertical line through the relation without touching more than one point at a time. So you might be wondering, well, what would it look like to not be a function? Well, I'll show you. I'll just put another point right here. I'll use red because it's not really there, and you don't need to draw it on there. But if I had, let's say that was another point at the same time, as I move this vertical line across, crash right there. Okay, right there we see that is intersecting 2 points at once. Therefore, that would not be a function because that particular output, whatever this x value is outputting 2 values here and here at the same time. Okay, so we can't call that a function. All right, but that's not really there. So when that's gone, this is indeed actually a function because no multiple points are not uh, touching the vertical line at once. So that's another way to determine whether or not something is a function for you. Okay, I'm going to hit pause and continue with video 2 next.